Hi, welcome to today's tutorial on fractional equations. So hopefully you've looked at the other tutorials on one-step, two-step and three-step equations. A lot of the two-step equations and three-step equations do involve fractions. So we're going to look at a very basic one to start with, and then we're going to go quite challenging. Again, these that do get very challenging, so just make sure that in your scheme of work or in your textbook that these are the questions that you actually need to be able to do, because they do get quite difficult. The first one most of you should be able to do anyway. The first one we'll look at: solve 2x plus 10 all over 4 equals 11. Okay, so what's the aim of solving an equation? Well, we need to find the value of x. So that means in this case we need to eliminate the 2, the 10 and the 4 from the left hand side, so at the end of it I've got x equals and my answer. Okay, so how do we do this? Well, which one can I get rid of first of all? We used that analogy previously in terms of which is the weakest number to get rid of. Well, obviously the 2 and the 10 are both upstairs. The 4 is the easiest one to pick on. So what's the opposite of divided by 4? Well, it's times by 4. Let's rewrite it. 2x plus 10 equals 44. Okay, now we're left with two numbers. Which can I get rid of first, the 2 or the 10? Well, it's the 10. Opposite of plus 10, minus 10. So now we're left with 2x equals 34. We've got one last step now. How to get rid of the times 2? Well, it's divided by 2. And that's going to be a nice whole number. X equals 34 divided by 2. That is going to equal 17. So I've got my answer there of 17. Like all questions, we can double check this by putting, or substituting should I say, the number in. 2 times 17 is 34. 34 plus 10 is 44. 44 divided by 4 equals 11. Correct. Okay, nice easy one to start with. So let's have a look now at a more challenging question. X plus 5 over 4 is equal to x plus 4 over 5. Okay, so this time both sides of my fractions, or both sides of my equation, sorry, are fractions. Okay, and it's a double-sided equation because I've got letters on both sides. So let's have a look. In the first step, I want to get rid of both the 4 and the 5. They're both those numbers are by themselves, and I can't deal with when things are on the bottom. I can't really deal with them too much, so I need to get rid of them. So how can I get rid of the divide by 4? Well, we need to times the left, also the right hand side by 4 if it changes sides. But remember, I'm going to put these in brackets because we need to times everything by 4. Okay, the whole side. Likewise, if I want to get rid of this divided by 5, I'm going to times the left hand by 5. Okay, because obviously the opposite of divide by 5 is times by 5, but it has to be the whole side. So what we're actually going to have, and for this step I'm going to write it like this. Just clean it up so we can see what's going on. So what I've simply said there, as you can see, it's kind of like cross multiplying. Okay, I've got divide by 4, the opposite of that is times by 4. If I move the divide by 5 to the other side, it becomes a times by 5. So what's 5 times x? Well, that's 5x. 5 times 5 is 25. 4 times x is 4x. 4 times 4 is 16. And it's a nice double-sided equation. So you get the numbers on one side and the letters on the other side. In this case, we've got the 5x is the biggest on the left-hand side. So let's move the x's to that side. So how do I get rid of plus 4x? Well, it's minus 4x. And how do I get rid of plus 25? It's minus 25. So I'm left with, well, 5x take away 4x is just 1x. And 16 take away 25, well, that's going to be a negative number, isn't it? It's actually going to be a negative 9. And so my final answer is x equals negative 9. Okay, quite a difficult question. Okay, let's go one more challenging, a little bit more challenging again. So we've got, this is number 3, e over 3 plus e over 2 equals 8. Now we spoke about the last question where we said that when the numbers are on the bottom, we can't do too much with them. It makes it really challenging. So one of the main ideas is to get rid of these fractions on the bottom. Now these are two different numbers. There is only two fractions on the left hand side, there's no fraction on the right hand side, so it makes it even more challenging. So watch a little trick I'm going to show you. Now remember, if we times everything by the same number, we don't actually change the value of the equation. We just change the numbers. Okay? It's like having, I guess, a fraction like, let's say 5 over 10 is the same as 1 over 2, which is the same as 50 over 100 or 1,000,000 over 2,000,000. They're different numbers, but they have the same value. So my little trick I'm going to show you is, what number does both 3 and 2 go into? Well, they both go into 6, don't they? An easy way of doing that is just times 3 times 2 together. So what I'm actually going to do, I'm going to times everything by 6, the whole lot. Remember, if I times everything by 6, I haven't actually changed the value of the equation, just the numbers. So what that makes it, now I could do 6e over 3 plus 6e over 2 equals 6 times 8. But the whole idea of doing this is, what is 6 divided by 3? Well, 6 divided by 3 is 2. What is 6 divided by 2? Well, 6 divided by 2 is 3. Okay, so when I rewrite that, I'm going to have 2, and I've just got e, plus I've got a 3e, and 6 eighths are 48. All of a sudden, by doing that, by timesing everything by 6, I've got rid of these fractions on the bottom. Okay, quite a difficult concept, I know, but after a few times of doing this, you'll get the hang of it. So again, I look for a common number that they both go into, similar to a common denominator, I guess, but then I'm going to times everything by that amount, and by doing that we can simplify the fractions. So what's 2e plus 3? Well, that's 5e equals 48. So my answer here, well, what's the opposite of times 5? What's divided by 5? That's not going to be a whole number. Okay, so I can just leave that as e equals 48 over 5, or if you want to go further and put that as a fraction, I guess, you know, you're more than welcome to do that, which is going to be 9 3/5, okay, or 9.6. Okay, quite challenging question. We're going to do another one. Okay, so this time we're going to do 2a over 5 minus 1 equals 3a over 2. Okay, quite similar to the last question. However, it just looks a little bit different. The numbers are on different sides. It's a double-sided equation. But the same format applies. I can't do with the 5 and the 2 on the bottom. So what I'm going to do is look for a number that 5 and 2 go into. Now, in this case, 5 times 2 makes 10. So let's times everything by 10. Okay, so I'm going to put a 10 in front of there, a 10 in front of that, and a 10 in front of that. Remember, we've got to times everything by 10. Remember the whole reason we do that? Because what's 10 divided by 5? Well, that equals 2. 10 times 1, well, that's just 10. 10 divided by 2 is 5. Now again, it's up to you on how you do the second line. You don't need to do the second line. You might actually do what we did last time and put the 2 up here and the 5 there. It's up to you on how you do that. I'm just showing you exactly where we come from. So we now have 2 times 2a is 4a minus 10 equals 15a. Okay, so it's a two-sided equation or a double-sided equation. The biggest a is on the right-hand side, so I'm going to go to that side, make things easier for myself. Okay, so how do I get rid of, remember this is a plus 4a. How can I get rid of plus 4a? Well, we minus 4a. So we're left with minus 10 equals 15, take away 4, well that equals 11a. Now I need to get a by itself, so what's the opposite of times 11? let's divide by 11. It's not going to be a whole number, so it's just negative 10 over 11. Okay, and that's my answer. Again, you can see that's quite a challenging question, but if we take each step at a time by first eliminating those fractions up on the top, rewriting it, getting a double-sided equation, it makes it much easier. Okay, we've got one last question to go. Again, I'm really up in the ante in this one, guys. Okay, so only attempt question 5 if you understand everything that we've done so far, because this is going to be more challenging. So we're going to have 12u plus 3 all over 7 equals 2u minus u plus 4 over 6. Okay, this is a really challenging question, guys. Maybe you want to pause it and have a go at it, see how much you can come up with. That's up to you. Okay, so like the other questions here, we've got a couple of fractions here, not the whole thing, so let's try to get rid of those fractions by finding a common number to times everything by. Well, what do both 7 and 6 go into? Well, again, if you're not sure, just times them together. That will give you a very quick answer. 7 times 6 is 42, so what I'm going to do, I'm going to times everything by 42. As you can see there. Okay, so the whole idea of that again is so I can eliminate these. 42 divided by 7 equals 6. 42, well, there's nothing to eliminate there. 42 divided by 6 equals 7. Okay, and now let's simplify. Okay, so we've got 6 times 12u. It kind of doesn't look like 12 there, does it? 6 times 12u, well, 6 12s are 72u, plus 6 3s are 18. 42 times 2u is 84u, minus, and we've got 7u minus, make sure, a minus 7 and a minus 4. Okay, so minus 7u plus 28. Okay, look at that. That's a really tough question. So now we want to simplify things where we can. Well, we've got 72u plus 18 equals, what's 84 take away 7? 84 take away 7 is going to be 77u.